Hello viewers, today in computer networks, I am going to take the topic Introduction to Transmission Media, and I am Dr. P. Ramadevi from the Institute of Aeronautical Engineering. Let us start. First of all, before going to the transmission media, so let us understand what are all the different terminologies behind this transmission media. So what is transmission impairment? The signals travel through transmission media. So, what is a transmission media? Here, whenever the sender wants to send any data, so that data has to be sent through a proper channel. So, the channel used for transmitting from the sending end to the receiving end is known as the transmission media. Medium is a singular and media is a plural. So here, what are all the transmission media used to transmit the data or the information from the sending end to the receiving? So whatever the signals are there in the form, the data in the form of signals, they travel through the transmission media. So when they are transmitted, they are not perfect. So because there are several causes of imperfection. So that imperfection is known as the signal impairment. So the signal at the beginning of the medium is not the same whenever when we are transmitting the data. So that when we are transmitting it due to the when it is transmitted through the medium, or else when it is transmitted due to the interferences externally, internally created. So because of that, whatever the signal we are sending it, it may not as it is traveled through to the distant places, so there may be an interference for that. So because of that one, the beginning of the medium, it is not the same whenever we transmit the signal as a signal at the end of the medium. So whenever we are transmitting it at the end of the medium, the signal may not be same. So sending end, we connect the medium, and then at the receiving end the same medium continues. But what happens is that when it transmits through the medium, the signal may get impairment. So what are all those impairments? Let us learn. So whatever we send, it is not received properly. So there are all we have three causes of impairment. Impairment means imperfection. So what is the imperfection? Attenuation, distortion, and noise. So the signal, whatever we are transmitting it, when it is transmitted through a medium, then the signal may get attenuated, or it may get distorted, or because of the noise, it may not be reaching to the destination properly. So let us understand what are all the what is distortion, attenuation, and then noise. So here the causes of impairment. Why there is a cause of impairment. Impairment causes due to the attenuation, distortion, and then noise. So what is an attenuation? So attenuation is nothing but a loss of energy, or you get a weak signal when that is attenuated. Whenever a signal is sent, so what happens is there is a loss of energy of that particular signal. Because of that, at the receiving end, we get a weak signal. That means the signal strength will be less. So when a signal travels through a medium, it loses energy. So because of as it travels through a medium, so there is a loss of energy. So that is overcoming the resistance of the medium. So there will be a loss of energy will be there. So why? Because there is a lot of resistance of the medium. So because of that one, so when there is more resistance, means the signal will be weak. So because of that one, to strengthen the signal, we go for an amplifier. So as you see here, if you reduce the resistance, then what happens is the signal strength may increase. That is, we know according to the Ohm's law, the current is proportional to the voltage. So whenever the current, according to Ohm's law, we know that the 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 voltage is proportional to the I. So what is the proportionality constant here? V is equal to R into I. R is the proportionality constant here. So when you want the signal to be, then we know that R is equal to V by I. So if you want to increase the signal strength, means so R is equal to V by I, and also suppose if you want the signal to be transferred, I is equal to V by R. So when you want to increase the signal strength, means when you want to increase the signal strength, the resistance has to be reduced here. But here, as we see here, because of the medium, as the resistance of the medium is more, so because of that one, the signal is getting, we get a loss of energy of the signal. So hence here the solution is using the amplifiers. So amplifiers are used to amplify the signal. So wherever required, the at the receiving end, the amplifiers are used, and then whatever the signal strength is there, that signal strength, weak signal, will get amplified by using the amplifiers. So these are used to compensate for this loss of energy by amplifying the signal. So by using the amplifiers, the signal strength is increased. So here, as you see here, the original signal is this is the original signal. So variation in the amplitudes of the signal is there. So that signal at the point 1, it is transmitted. This is the original signal, what we want to transmit it. And when it is transmitted through the transmission medium may be some cables, optical cables, or else through coaxial cables. That is the transmission medium. And even wireless also, through wireless also we will transmit the signal. So those are nothing but the transmission medium. So through the transmission medium, the original signal is transmitted. So what is the meaning of at point 2? You observe that there is a change in the signal. What we get at the point 2 is a weak signal. As you see here, the amplitude of the signal is reduced here as compared to the original signal. This signal is, as you see, this is the amplitude, and this is the amplitude. As you see here, as you see, they have, it has the more amplitude, but the original signal has the here the after attenuation, the signal amplitude is reduced. So hence, by using the amplifiers, the signal amplitude can be increased. So it is amplified, and then the original message is, we are getting the original signal back. So at point 3, by using at the receiver section, if we use an amplifier, the original signal we will get back. So this is nothing but the attenuation of the signal. So next one is the distortion. What is distortion? What is the difference between attenuation and then distortion? So with the pictorial representation, we will understand what is distortion. So first of all, we'll understand what is distortion. This is a signal changes its form or shape. So as you see, distortion means the signal will change its change its form. Form means shape. It will change its shape. So distortion occurs in composite signals. The distortion occurs in composite signal, means it is a combination of video signal, audio signal, all these many signals, or if they are combined, and then we call it as the composite signals. Frequently, these changes in the shape will occur in the composite signals. Each frequency component has its own propagation speed traveling through a medium. So here a composite signal will have several frequency components. So let us say signal 1 will have frequency f1, and signal 2 will have frequency f2. Signal 3 will have frequency f3. Signal n will have frequency n. So like that, each frequency component, it has its own propagation speed. So each will travel through a medium. Each signal will have its own speed to travel through a medium. So different components therefore arrive with different delays at the receiver. So because of this one, as they have different frequencies, as they have different propagation speeds, because of that different frequency components, the propagation speed also varies. So as the propagation of the speed varies, because of that they arrive with different delays. So the one will occur, suppose at a time t means another will occur at that time, another will arrive at a time t2. So like that, different delays at the receiver will take place. That means the signals have different phases at the receiver than they did at the source. So whenever all signals, they have different phases also. So phases means phase angles. So each signal will have different phase angles at the receiver. So because of that one, so hence there are chances of distortion occurring during that time. So let us suppose we take, for example, at the sending end, the composite, this is the composite signal at the sending end. The composite signal consists of, this is the component signal, which is a combination of several frequency components. So all these are several frequency components. So as this we see, the components, as you see, these are in phase. They are at the sending end. You see the this one at the sending end, where it is starting, this is all are in phase. They are starting at 0. All are at the sending end, starting at the 0 angle, and then they are ending up at 30 degrees, or again at the 0. This one cycle, if you consider. So here it is the 0, pi, 2 pi, then 3 pi, then 4 pi, like that. It will have, for each and every positive and negative excursion, will have the 0 to 2 pi, that is 0 to 0 to 360 degrees. So like that, so as you see here, they are starting and all are having, they are all in phase. We call these components are in phase because all are starting at the same phase, say phase angle. So here at the receiving end, as you see here, these are the signals. So as you see here, if there is a distortion present at the receiver, means when it travels through a transmission media, so there occurs a distortion in the signal. So here the phase angle, as you see here, it is first the signal. This signal is starting at 0. But as you so far after a time being, this signal, due to the transmission media impairments, so because of that, due to distortion, so there occurs a change in the phase. So here this one is at the 90 degrees phase. It is out of phase. Then this one is also here. Also, it is starting at the this one is the it is starting at the out of phase. That is a negative. It is starting at this point. So here at the negative, it has the negative amplitude. So from that it is starting. So all these are the different phases. So like that, we can say that this is components are out of phase. So they are not in phase, they are out of phase. So this is the composite signal received. So as you see here, because of the change in the phases, there is a change in the shape of the signal. Here you see there is a change in the shape of the signal. So like that, if there is any impairment because of the distortion, this is the effect. Noise. There are different types of noises are there. So noise will be created when the signal travels through a transmission media. there may occur there may occur noise. Noise means disturbance. So disturbance caused because of some reasons. So what are the reasons? First one is the thermal noise. This thermal noise is nothing but it is a random noise of electrons in the wire creates an external signal. So extra signal. So here the because of the thermal noise, because of thermal means heat. So because of the heat or radiation, because of the radiation, so this is a random noise which is generated because of the electrons in the wire. So this creates an extra signal will be created because of this one. So hence that's why there is a distortion or there is a hence there is a disturbance in the signal. Then in the induced noise. What is induced noise? We have suppose when the signal is going through the medium, so there are another noises added. So when from motors, from any appliances, if we are using it, any devices, all these they are act as transmitting antenna. So when they act as a transmitting antenna, so and medium as receiving antenna, so they act as a transmitting medium, and then the whatever medium we are using that medium itself acts as a receiving antenna. When they both are acting as a transmitting antenna and then receiving antenna, so the signal some unwanted signal is added with the no, with the transmitted signal because of this in the induced noise. So next one, another one is crosstalk. Crosstalk is it is nothing but the same as the above. That means it is because of the different appliances, motors, different devices, but it is between the two wires. That means where crosstalk occurs at the sending end and receiving end. Suppose both the signals are they are collided. So because of that one, there occurs a crosstalk. So because of that one, when at a time both signals are transmitted, means no one will receive it. There will be unwanted signal which is added because of this one. So between two wires, if it is two wires, if between the two wires the noise is created, means we call it as crosstalk noise. Then impulse noise. Impulse noise means you will get spikes that result from power lines, lighting and all. If there are because of the lighting or because of the power lines, what we are using it. So through transmission media, when we are transmitting to the longer distances, we come across such several types of noises. So because of that one, spikes are created. Spikes, we call it as the impulse noise. So we'll understand what is noise in the signal. So let us understand with the help of the pictorial representation. At the transmitting end, let us suppose this signal is transmitted. When this signal is transmitted at the point 1 through the transmission medium, and so this because of the different appliances, devices present through the transmission when we are transmitting it, it's all this because of those devices. There occurs a signal will be there, but there will be a disturbance in the signal. There will be an unwanted signal added with the. There is an unwanted noise. We can define it as an unwanted signal. So this is a signal, but we are getting extra signal one is which is this is the impulse signal. Also it has the highest amplitude at a finite time. It will have the infinite amplitude. So that is nothing but an impulse signal. So that impulse signal is added with that of the original signal. So when it is transmitted to the transmitter medium, at the receiving point, you are getting the signal, original signal, which is added with the unwanted at the receiver section. We get an unwanted signal which has the spikes. So we have several types of noise. We have several types of transmission media. So, guided media, unguided transmission media. Guided transmission media, they are guided. Guided means they are used with the help of wires. So the signal is guided. Guided means you through the wires it is guided. So hence that's why we call such type of classification as the guided transmission media. Unguided transmission media means there will not be guided at all, it will be transmitted randomly. So because of that one, it is not a wired, it is a wireless transmission media. We call it as the unguided transmission media. The wireless transmission is done by using the unguided transmission media. Guided is wired transmission. The characteristics and quality determined by medium and signal. So all the characteristics are they are all determined by the whatever the characteristics and the quality of the transmission media is determined by the medium and signal. For guided, the medium is more important. For the guided one, medium is very important. What medium we are using it, whether it is a coaxial cable or it is a optical cable. So the medium of transmission is important for the guided. For the unguided, that means for the wireless transmission media, the bandwidth produced by the antenna is more important. So whatever the antenna we are using it produces some bandwidth. That bandwidth is very important when we are concerned about the unguided transmission media. The key concerns are the data rate and distance. So why we go for guided and unguided transmission media? Guided transmission media, if you want to travel for kilometers and more than kilometers, several thousands of kilometers and all, the wire transmission, physical wires are nothing but the physical wires, physical connections. So physical connections cannot be installed for the longer distances. Hence, we go for the wireless transmission. So because of that one, through Wi-Fi or through satellite communication, we can send the data. So because of that one, if we go for and we can increase for the data rate can be increased, and then because of the distance, more distance we go for the wireless transmission, and then distance constraints and data rate also. So the data rate can be increased by using the wireless transmission. So hence, suppose if we want to reach it to the longer distances, the transmission, then we go for the data rate has to be increased or it has to be maintained. So hence, these are the key concerns: data rate and the distance. So there are several design factors for this transmission media. What are the design factors? Bandwidth. So bandwidth. So width of width of the band should be higher. It gives higher data rate. So if the bandwidth is more, means the data rate of data. The what is rate of data? Number of bits transmitted per second is the data rate. So the data rate we can increase higher data rate will be increased will be achieved by using higher bandwidth. So transmission impairments. Transmission impairments? Transmission impairments are nothing but attenuation. Then the interference also will occur because of the electromagnetic waves. Because of that, there occur the interference. So another factors are these are the several factors which affect the transmission media, the bandwidth. Then another one is transmission impairments, then interference, then the number of receivers. So suppose if some number of receivers, so depending on the transmission media, the number of receivers have to be installed. So we have to concern about the number of receivers also. So this can be in the guided media. more receivers, receivers means if we have more receivers, we can also specify it as the multi-point. So if you have more receivers means it introduces more attenuation. So hence all these factors have to be considered while designing a transmission medium. So these are all the designing factors: bandwidth, then transmission impairments, attenuation, interference, number of receivers for the guided media. More receivers means more attention. We have discussed about the several transmission media impairments. So what are all the causes of the transmission media impairments? So this one is the impairments because of the media is the attenuation, distortion, and noise. So we have seen the difference between what is attenuation, what is distortion, what is noise. So all with this we complete the so all these we have discussed with the help of the pictorial representation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.